Hello students, this is Mr. Ezra. In the last video we derived what is called the quadratic formula, and today we're going to look at a part of the quadratic formula that we call the discriminant. Discriminant tells how many and what type of solutions the quadratic has. A quadratic always has two solutions, and what the discriminant is going to tell us is what those two solutions are going to kind of look like, what type they are. It is important that before we do anything with this formula that we put our quadratic in standard form first. In other words, that ax squared plus bx plus c. So if it's not already in standard form, we're going to have to move some things around and get it in that form. So let's look at a few examples. Let's talk about what exactly the discriminant tells us. We really plug in our b, a, and c and do the math, and we really care mostly about the sign of the number that we get. If that discriminant, once we plug in a, b, and c, is positive, that means that we have two real roots, that our solutions or our roots are going to be real numbers. I'm going to skip down here. If the discriminant is negative, well, that means that we are going to have two imaginary roots. And if the discriminant is 0, we're going to have one real root. Now, quadratics always have two roots, right? And when I say one real root, that one real root is actually what we call a double root. What that means is algebraically the root would occur two times. But when we look at a graph, the quadratic would, let's say here is our x and y axis, right? The quadratic would probably touch in just one place, right? So on the graph, it would look like one solution, and algebraically would give us one solution, but it would really be two solutions that happen to be exactly the same number. So if you think of that as a double root, that's a good thing to go ahead and start understanding. So we either have two real roots, one real double root, or two imaginary roots. And those are the three choices. So you just need to know, is this thing, once you do the math, positive, 0, or negative? So here's our first example. We've got our quadratic, and the first thing you kind of want to ask is it in standard form? Ax squared plus bx plus c equals 0. It is. In this case, a equals 1 because there's a leading coefficient in front of x squared. It's invisible, but it's 1. The b is negative 3, and the c is positive 4. So we know our a, b, and c, and we're basically just going to plug those things into this formula for the discriminant. And if you remember the big quadratic formula that we derived, it was negative b plus or minus the square root of b squared minus 4ac all over 2a. And this was in the formula under the square root sign. Well, we don't want to use the square root sign to find the discriminant. We just want to find the b squared minus 4ac by plugging in b, negative 3, squared, minus 4 times a, 1, times c, 4. Now make sure that if you have a negative number anywhere in here that you put it in parentheses, because negative 3 squared negative 3 squared without the parentheses in your calculator could give you the wrong answer. What you want when you square negative 3 is to get positive 9. And then, of course, negative 4 times 1 times 4 is negative 16. So what does this mean? Well, our discriminant is negative 7, and what the really important thing for us to look at is the sign. This discriminant is, let's use a different color, this discriminant is negative. So what does that negative tell us? It means that we have two imaginary roots. It means if we were to do all of the math to find these roots, they would be imaginary roots. Now, we'll talk about this a little bit later when we start looking at graphs, but just as a kind of a preview, what does that mean on the coordinate plane? If all of these quadratics that we're dealing with, well, they could be graphed as what we call a parabola. And two imaginary roots just basically means that the parabola does not cross the x-axis, right? The roots are not real because the x-axis is a real real number axis. Instead, the roots are imaginary. So that's what happens. That's why we have two imaginary roots. But for this lesson, really, you just have to look at the sign and say, oh, it's negative. That means there's two imaginary roots. I'm done. Those are the number and type of roots. There's two of them, and they are imaginary. Example number 2. Again, this is already an ax squared plus bx plus c form equals 0. There's nothing on the right side. It's in descending order over here. So we'd say a is 1, b is -4, and c is 4. And we would take that a, b, and c, those numbers that represent a, b, and c, and we'd plug them into the discriminant formula. And once we do that, we get -4 squared. Again, remember your parentheses, because it's a negative b, it needs to be in parentheses, minus 4 times a, which is 1, times c, which is 4. But after plugging those in, you can put it all in your calculator at once, or you can do the left part squared. -4 squared is positive 16. The right part squared, you just multiply all three of those numbers together, -4 times 1 times 4, to get negative 16 or minus 16. And 16 minus 16 is, well, 0. Well, 0 is that case where it's not positive, it's not negative. So what we have is one real root, and that one real root is technically what we call a double root. All right, so that is example 2. Example 3. I've already got this one in descending order in standard form, ax squared plus bx plus c, where a is 1, b is -5, and c is 4. So we plug those into the discriminant formula and we get -5 in parentheses squared. Let me get out of there. -5 in parentheses squared minus 4 times 1 times 4. -5 squared is 25. -4 times 1 times 4 is 16. 25 minus 16 is a positive number. It's a positive 9. And whenever it is positive, not negative, not 0, that means we have two real roots. It'll actually work out to give us two real solutions. That is it. The discriminant is super easily. If you can remember b squared minus 4ac, and you can plug the numbers in correctly and use parentheses appropriately, and either multiply and add to numbers in your head or with your calculator, you're going to be fine. It's a piece of cake. It's a cakewalk. All right. So next video, we'll not just look at the discriminant and the things that it tells us, but we'll dig further and actually use the quadratic formula to solve some quadratic equations. I will see you in class.